Hi, welcome to the screencast for the adaptations of the cardiovascular system. So this is what we're going to be going over for the next couple of lessons. When we're talking about adaptations, what we're talking about is our cardiovascular system becoming stronger, fitter, and potentially just more able to cope with the demands of exercise. So you tend to get adaptations of the cardiovascular system after a kind of like purposeful or well-planned training program that lasts between 6 to 8 weeks. So if you take a training program 6 to 8 weeks, you are going to get these adaptations, and these adaptations of the cardiovascular system are going to improve your performance over a period of time. So these are the Cornell note headings I want you to get down. Now there seems like quite a few here, but do not worry, some of them are very minuscule, do not have much. This is the same within lessons. You're learning a lot of these, increase in blood cardillae. So if we could appreciate that ourselves. So first heading, what is it? The enlarged wall of thicken underneath. Here's a picture. This is here. Then after 4 of its contract oxygen leaving the heart, what we want for I would put that the left ventricle means that the left that will do that. So that's what I want for each one. So that's cardiac hypertrophy done. Okay, increase in resting and exercise stroke volume. Now remember, stroke volume is the amount of blood pumped up the left ventricle per beat. So an adaptation of training is we get more blood leaving the heart per beat. That is the main thing about stroke volume. So more blood is pumped out the left ventricle per beat. This is due to an increase in venous return, i.e. the amount of blood going back to the heart. Now, as I said, we are going to go on about this in more detail in lesson, because I'm going to go through venous return in more detail. We're also going to go through something called Starling's law. However, just for these corner notes, all you need to know is one of the adaptations of the cardiovascular system is an increase in stroke volume, which means more blood is going to be pumped out of the left ventricle per beat. This in turn, you don't need to write this down, okay? This in turn will increase our cardiac output, which means more blood is going to be pumped out of the left ventricle per minute. So whenever you're talking about stroke volume within an exam question, it's likely you're going to have to mention cardiac output because, as you know, cardiac output is heart rate times stroke volume. So if stroke volume increases, cardiac output is going to increase. Okay, that's that one done. So decreased resting heart rate and decreased resting blood pressure, got both on this slide because they're very small. So cardiac hypertrophy, i.e. the enlargement of the heart, and an increase in stroke volume, i.e. the amount of blood that leaves the heart per beat, means that our resting heart rate will drop, i.e. our heart rate does not have to beat as many times in a minute to get blood, therefore oxygen, to the working muscles, because with each beat we're getting more oxygen to the muscles, so it doesn't need to beat as much. So the healthier you are, the lower your heart rate will be. Okay, and then decreased resting blood pressure. All you need to know is that research shows that regular exercise can contribute to the reducing blood pressure, particularly those suffering from hypertension. So your question for this may be, what adaptation of the cardiovascular system will help sufferers of hypertension? And your answer would be a decreased resting blood pressure. Decreased heart rate recovery time. So training will result in heart rate recovery quicker after exercise. That's all you need to put for that. And then just a little bit of an extra point is fitter athletes will bring their heart rate down much quicker than untrained individuals. This just means that with recovery time being better, it means that you're going to be able to have an advantage over an opponent because you're going to be able to train the next day at higher intensities where they are not going to be able to. Okay, capillarization of skeletal muscle and alveoli. So capillaries, remember, is where gaseous exchange takes place. So capillarization means we're going to have more capillaries. So there's going to be more capillaries around, for example, the quadricep after training. After a 6-week training program, more capillaries around the quadricep muscle. That is capillarization. So a better capillary network in the body will increase blood flow to the working muscles. What does this mean? Obviously means more oxygen is getting to the working muscles and more carbon dioxide is being removed from the muscles, which means we're going to be able to perform for longer at higher intensities. So capillarization is an increase in the capillary network, which means more blood will be going to the working muscles, and therefore oxygen, and more carbon dioxide will be removed. We have also an increase in capillarization around the alveoli, so there'll be loads of more capillaries in someone that trains regularly in comparison to someone who doesn't, which means that more oxygen is going to be able to enter the bloodstream. And again, as I've said, more carbon dioxide is going to be able to be released into the alveoli and breathed out. Increased blood flow. So increased blood volume. So blood volume increases as a result of capillarization. So the more capillaries we have, the more blood volume we have. This means that the body can deliver more oxygen to the working tissues and remove carbon dioxide. Also means that blood volume will regulate body temperature more efficiently. So they are your corner notes for the next 2 lessons. So ensure that you do them so that you have them prepared for the next 2 lessons, as I've said. Tomorrow's lesson, more than likely, it's going to be more about stroke volume, but we will go through some of these. So if you can get that done, I'll appreciate it. Thank you, and I'll see you tomorrow.